Okay, so yesterday we have ended on question number 2 and we are doing May-June 2023 paper 2-2. So let's start with question number 3. Figure 3.1 describes a sequence of reactions that can be used to produce a food additive compound Y from CH3CH2Cl. Okay. Now, before heading towards the options, I'll suggest que solve this, then it will be very helpful for you. So see, here there is a Cl and here there we are getting Cn. So if you recall that for this reaction, when we have to get a nitrile, we use potassium cyanide or sodium cyanide, and that cyanide must be in ethanol. And for that, we have to do the heating. In step 2, if you see dilute hydrochloric acid is used and that nitrile turns into ethanoic acid. If I talk about the first reaction, it is nucleophilic substitution. If I talk about the second reaction, they have mentioned the reagent, and that is, this reaction is hydrolysis. Is this understandable, Saeed and Abdullah?
Yes, sir.
Now in the third reaction, we are adding Ca. So it's an acid and we are adding Ca. Calcium have a +2 charge. So what will happen over here, that CH3, CH2, COO negative and calcium 2 positive. So Y will be CH3, CH2, COO twice Ca. Okay, so it is an acid metal reaction. So the first reaction is nucleophilic substitution, second reaction is hydrolysis, and third reaction is acid and a metal reaction. State the reagent and conditions for step 1. So we have already figured out, so we just mentioned over here that potassium cyanide in ethanol, that is the reagent, and condition will be heating. So we will just write heat, or you can just write reflex as well. Give the systematic name of X. So how many carbons are there in X? 3 carbons and a nitrogen bond triply bonded to carbon. So 3 carbons make it propane, and as a nitrogen bonded to a carbon with a triple bond makes it nitrile. So its name will be propane nitrile. Is this understandable?
Yes, sir.
Now, in the third, identify the type of reaction that occur when dilute acid is added to X in step 2. So we have already identified the type of reaction. It is hydrolysis. And more specifically, we can call it acidic hydrolysis because the reaction taking place by adding an acid. Is this clear?
Okay, sir.
Yes, sir.
In step 3, Y and a gas are produced. Construct an equation for step 3. Okay, so you have to write the equation. So in step 3, our reactant is CH3, CH2, COOH, which is reacting with calcium. So if I recall the word equation, when there is an acid and it is reacting with the metal, the two products that we get, one is a salt and the other product is a hydrogen gas. So we figured out the formula for a salt, that it is going to be CH3, CH2, COO taking twice, Ca, and then H2 gas. To balance the equation, I have to put 2 over here. Now the equation is balanced. Is this clear?
Yes, sir.
Now, B part. Propanoic acid, it's a propanoic acid, right? Can also be formed from propane -1-ol. So it means that they are saying that alcohol is forming a carboxylic acid, right? and potassium dichromate. Potassium dichromate is reacting with an alcohol. State the conditions required. So yes, it's, if you recall, this reaction is, isn't it an oxidation? And for that oxidation, what conditions are required? If you recall, we need a acidic condition, we need a acidic medium. We always use potassium dichromate and potassium magnate in acidic medium. If you recall, we use acidic potassium dichromate, we use acidic potassium magnate, and the other one is that whenever we get a carboxylic acid, we have to heat the reaction mixture under reflux. So these are the condition: heating and heat under reflux, acidic conditions and heat under reflux. Is this clear? Yes. Yes, Abdullah.
Clear.
Saeed, is it clear to you as well?
Sir, can you explain heat under reflux?
I think you forgot, we have discussed it in oxidation.
Yes.
Why you are not revising that? Yes. See, that is heat under reflux. Otherwise, it's a propane one all, which is a primary alcohol. If we do not do heat under reflux, instead we do this, then instead of propanoic acid, we will get propane, propanol, and aldehyde. For a complete combustion, we use heat under reflux. So this is heat under reflux. If you remember, we discussed it in detail when we did the oxidation, right?
Yes, I remember.
Okay. Any other question?
No, sir.
Okay. Complete table 3.1 to show the number of sigma bonds and pi bonds. So sigma bond is the single bond and the rest of the bond between single bond, or you can say the first bond between two atoms. And after first bond, whatever the other number of bonds that are made between the two atoms will be considered as a pi bond. So it's an X, right? If I show the displayed formula of X, then there are 3 carbon atoms, and one carbon atom have a triple bond with a nitrogen. The second carbon have a 2 hydrogens, and the third carbon have a 3 hydrogens. Now, how many pi bonds are there? Yes. Abdullah, how many pi bonds are here?
2, sir.
Very good. 2 pi bonds. Because there is a triple bond among these 3 bonds, the one bond is going to be sigma because it is the first bond, and the rest of the 2 bonds will be the pi one. Is this clear?
Yes.
Yes, Saeed.
Okay.
Now, how many sigma bonds are here? One sigma bond is here. This is the sigma bond. This is the sigma bond. This is the sigma bond. This, all are sigma bonds. So, how many sigma bonds are here?
7.
Count again.
8 is
8 sigma bonds are here, starting from C triple bond and have a 1 sigma bond, and then there are 7 more sigma bonds, right? Yes, Saeed, is it clear?
Yes, sir.
Abdullah, is it clear to you as well? Yes, Abdullah. Hello, Abdullah.
Yes, sir. Clear.
Okay. Now, question number 4. In industry, ethanol is made by reacting ethene with steam in the presence of phosphoric acid. So, presence of phosphoric acid is a catalyst, and steam means H2O, water in a gaseous state, and ethene is C2H4. Use the bond energy values in table 4.1. Calculate the enthalpy change for the reaction 1. Okay, here we have a reaction 1. Let me draw a displayed form of reaction 1. There is a double bond between two carbon atoms in C2H4, and each carbon is bonded to two hydrogens. Then we have a H2O, and then we have a C2H5OH, which means that the double bond is broken down. Now there is a single bond between two carbon atoms. One carbon got H and the other carbon got OH. So from the bond energy values, if I have to find the enthalpy change, so the enthalpy change will be equals to enthalpy of bonds broken minus enthalpy of bonds formed. So if you see the bonds that are broken is this carbon-carbon double bond and one OH bond, and the bonds that are formed is this carbon-carbon single bond, then carbon-oxygen single bond, isn't it? So
Yes.
what we have to do, the bond energy for these, which the bonds which are broken, is this one and this one, and the bond energy for the bonds formed are this one and this one. Now we have to take the value. So the bond broken, one is 610, the other bond broken is 460. So we will add them. The bond formed, one is having a bond energy of 350 and the other one having a bond energy of 360. Add them. So 1190 kilojoules per mole is the bond energy for bonds which are broken, and 710 is the bond energy for the bonds which are formed. Oh, there is, I think I did a mistake. Yeah, there is, this bond is also formed. So there is one more bond that is formed over here, and it is CH bond. So 410 as well. Now 1120. So 1190 minus 1120 gives me 50 with a positive sign. So the enthalpy change of this reaction is 50 kilojoules per mole. Is this clear?
Yes, sir.
Yes,
Yes,
sir.
Saeed. Okay. Now, reaction 1 reaches equilibrium at constant temperature and pressure. Deduce what effect increasing the pressure will have on the amount of ethanol in the new equilibrium mixture. Use Lee Chatwier's principle to explain your answer. Okay, who is going to tell me when we increase the pressure where the equilibrium will shift? Yes, Saeed, where the equilibrium will shift?
It will shift to that place where moles of gases are less.
Very good. Very good. Equilibrium. Shifts to the side having lesser moles of gases. So if we see over here on the reactant side, on the product side, we have a 1 mole of gas, and on the reactant side, we have a 2 moles of gas. So which means increasing pressure shifts the equilibrium towards right hand side, and as a result, the amount of ethanol will increase. Is this understandable?
Yes, sir.
Yes,
Yes,
Abdullah.
clear.
Okay, so effect, they have asked us the effect on the amount of ethanol. So we will write that amount of ethanol increases, and the explanation that what we have seen, that equilibrium is shifting towards right. Because right side or product side have lesser gas moles and have to reduce the increased pressure. Is this understandable to everyone?
Yes, sir.
Yes,
Okay. The mechanism for reaction 1 can be described in 3 steps. Step 1 and 2 for reaction 1 are shown in figure 4.1. Okay. So if you see in step 1, the double bond is attacked on the hydrogen, and this bond broken down hydrolytically. As a result, this hydrogen is now over here, and we get this ion. Now, in the second stage, water comes and water attacks on this carbon, and as a result, water is bonded with the carbon. Now it have a positive charge because it is forming 3 bonds. Describe the behavior of H3PO4 in step 1. Explain your answer. Okay, so you have to tell the behavior and then explain the answer, right? So as you see, isn't it the one which is producing the hydrogen ion, right? Because it is left with this negative ion, which means it produces the hydrogen ion. So which kind of compounds forms hydrogen ion?
Acid.
Acids, very good. So we will write acid, and we will explain it by writing it that it donates H positive ion. Is this clear?
Yes, sir.
yes, sir.
Now, in part 2, identify the species that behave as an electrophile. If you recall, electrophile is the one which is electron lover and the one which is basically electron deficient, which how can we figure out? Either have a plus charge or have a partial positive charge? Explain your answer. So in step 2, if you see in step 2, this got a plus charge, which indicates that it is an electrophile. So it is CH3CH2 positive, right? And why? Because it is an electrophile, because it is accepting this proton. Oh, sorry, this lone pair. So CH3CH2 positive is an electrophile as it accepts a pair of electron. Is this understandable to everyone?
Yes, sir.
Yes, Abdullah.
Yes, sir. Yes.
Now, in the third part, what they are saying, complete figure 4.2 to show the mechanism for step 3 and of reaction 1 include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Okay, so if you see over here, this oxygen must have a lone pair of electron, and from this lone pair of electron, it is going to attack this H4, and as a result, this bond is broken down hydrolytically by the oxygen as it takes away this bond pair towards itself. As a result, we will get this molecule, and this H is bonded to oxygen now, making this. Is this clear?
Yes, sir. Yeah.
Yes, Saeed. Describe how a catalyst affects a reaction. Explain your answer. And it's of 2 marks. So we know it increases the rate of reaction.
Without being used in it.
Yes, Abdullah. By providing an alternative route of lower activation energy. Yes, is this clear?
Yes.
Yes, sir.
Use figure 4.1 and 4.2 justify why phosphoric acid described as a catalyst in reaction 1. So if you see in figure 4.1, initially we have a phosphoric acid which is being used, taking part in the reaction, and at the end of the reaction it is reformed. So that reformation indicates that it is a catalyst. So we will write over here that H3PO4 acted as a catalyst because it is reformed. Is this clear?
Yes, sir.
Now, sixth part. Propene also reacts with steam. A mixture of organic product is produced. Explain why propane 2-ol is produced in the higher yield. So if you recall the reaction, propene is this compound when it reacts with steam, we have discussed that we are going to get two products. One is major and the other one is minor. Major one having a OH over here and hydrogen on the last carbon, and the minor one having a hydrogen over here and OH on the last carbon. So the reason is that if you recall, is due to the intermediate. In both the cases, the intermediate carbocation is formed. So that we will write that the intermediate carbocation for propane to all is secondary, which is more stable than primary, because the other carbocation would form having a positive charge on this carbon and on this carbon. There are two possibilities, right? So when this one become a positive carbon or carbocation, then we will get a propane two all, and when this one becomes a carbocation, we will get a propane one all, and that one is a primary one. So we will write that the intermediate carbocation for propane two all is secondary, which is more stable than we knew that the other carbocation is primary. So we'll write then the primary due to more positive inductive effect of more alkyl groups. Is this clear? So that's why it is going to be a major one and this one is going to a minor one. Yes, Abdullah and Saeed, is this clear?
Yeah.
Saeed, describe the covalent bonds present between carbon atoms in an ethene molecules by completing table 4.2. So in ethene, carbon have a double bond, right? So if the carbon have a double bond, which means carbon have a sp2 hybridization. So the sigma bonds are formed by the sp2 orbitals overlapping, and the pi bond is formed by the p orbitals overlapping. The sp2 orbitals overlap linearly to form sigma bond, and the p orbitals overlap in a sideways manner to form pi bond. Is this clear?
Okay.
Okay. Now, question number 5. Describe the structural isomerism. So you have to write the definition. Isomers having same molecular formula but different structures. Now, A and B are structural isomers with a molecular formula C5H10O. So if you see its general formula, it is going to be CnH2nO. And if you further recall, this general formula can be of an aldehyde or can be of an ketone or might be a structure having carbon-carbon double bond and OH, both the groups present in one structure. This table 5.1 describe observations when separate samples of A and B are added to different reagents. So in A, we are getting orange precipitates with 2,4-DNPH both A and B. So it means that both can be carbonyl. A is giving silver mirror test positive and B is not. So we can then conclude that A is an aldehyde and B is a ketone. With aqueous alkaline iodine, there is no reaction. So it means they both, one is aldehyde and ketone, but CH3 bonded to C double bond O is not present in the structure. The structure doesn't have C double bond O bonded to CH3 in both the cases. Name the functional groups present in both A and B. So the collectively aldehyde and ketone are called carbonyl. So we can write the functional group is carbonyl. And if you want to further elaborate, you can write that A is an aldehyde and B is ketone. Is this understandable to everyone?
Yes, sir.
Draw the structures of A and B. Now see, you have to keep this in mind that the structure doesn't have C double bond O on the second carbon. So if A is an aldehyde, so its structure would be CH3, CH2. The formula is C5H10O, right? CH2, CH2, 4 carbons, and the fifth carbon is going to be aldehyde. And in B, there is a ketone, so CH3, CH2, C double bond O, CH2, CH3. Is this clear? Yes, Abdullah and Saeed.
Yes, sir. In B, I
Yes,
can
sir.
put C double bond O anywhere, right? Except for terminal carbons.
Except
For terminal carbons, I can put C double bond in any carbon in B.
no, in not any carbon, because if you see there are 5 carbons, right?
Yes.
If you put this over here, it is ketone, but in this ketone that C double bond O is next to CH3, right?
Yes.
And here we have concluded that in these structures, C double bond O is not next to CH3.
Okay. Yes.
So then we got only possibility that it must be in the middle.
Fine, sir.
Now, C is the structural isomer of A and B. C is a straight chain and has 2 functional groups. So it is very obvious if it has a 2 functional groups and a straight chain. So it must have this one, the last one that I have concluded, that have a carbon-carbon double bond and OH. C only shows only one type of stereoisomerism. Describe observations when separate sample of C are added to different reagents. No reaction with 2,4-DNPH means no carbonyl. With bromine, orange to colorless means carbon-carbon double bond is present. Aqueous alkaline iodine, yellow precipitates are there. So it means that here that CH3 is bonded adjacent to CHOH group. Draw the structure. Okay, so if we got that it have a this structure, right? Just give me. Okay, so its molecular formula is also C5H10O. So CH3 CHOH. Just give me a minute, please. Sorry. Okay. So we put up two carbons. Now third carbon, fourth carbon, fifth carbon. Two hydrogens with this one, and there is a double bond, right? So CH double bond CH2. This is going to be the structure. And see, this carbon is a chiral carbon. So it is going to show us optical isomerism. And the double bond is on terminal. So it means there will be no cis and trans isomerism, right? And why I put a double bond on the center one, not here, because if I have put a double bond over here, then it can show optical isomerism and cis and trans both. But here it indicates that it shows one type of isomerism. So that is why I have to put double bond on the terminal, not on the middle. Okay. Now they are asking, name the type of stereoisomerism. So we know that it's have a chiral center, so it have a optical isomerism. Yes, Saeed and Abdullah, is this clear till here?
Yes, sir.
Yes, Abdullah.
Clear, sir.
Now, D reacts in the presence of sulfuric acid catalyst to form E and water. The structure of E is shown. So if you see that this is over here, which functional group is this? Okay, they are asking the functional group present in E. So yes, which functional group is this? Yes,
It is
Saeed.
ester.
It is
Ester.
very good. It's ester because there it is C double bond O, and that C is bonded to O, and that O is further bonded to C, indicating it's an ester. Very good. Identify the type of reaction that occur when D reacts to form E. So by which reaction ester is formed? What we call it? Condensation, because a small molecule of water is being formed along with the molecule of ester, so it's a condensation. Draw the structure of D. So, okay, to draw the structure of D, you have to break it from here. When you have break it from here, you will get this. There is a O. Here we have one carbon, and here we have another carbon. Now this O, put a H over here to make it alcohol, put a OH over here to make it carboxylic acid. So that's how ester is formed. When this H and OH is removed from here, this carbon is bonded with this oxygen to make a ester. Is it clear? Yes, Abdullah and
Okay.
Saeed.
Yes, sir. Yes.
Okay, great. Now, the last one. Infrared spectrum of E is shown in figure 5.2. Let me draw the E over here. E is this thing. Okay, here we got the table. Use figure 5.2, which is over here, table 5.3, which is over here. Predict two differences in the absorption above 1500 centimeter inverse of the infrared spectrum of D and 2E. Okay, that is E. Now, if you draw D, we have here OH group, and here we have carboxylic acid group. Okay, so one will be the signal of OH, right? Because OH is not E in E but D. So we will write we have OH of carboxyl, but actually we have alcohol as well, and of hydroxyl. So we got the two difference over here. At wave numbers, now we will mention their wave numbers, 2500 to 3000 centimeter inverse and 3200 to 3600 centimeter inverse. Respectively, which are not present in E. Yes, is this understandable?
Yes, sir.
Yes, Abdullah.
Yes, sir. Clear.
Okay, good. Now we are done with this past paper. Now in the next class, I'll try to start with the May-June 23 paper 2-1. Okay.
Okay, sir. Sir, can you send this paper?
Yes, I will be sharing this paper on the WhatsApp group. Okay.
Thank you, sir.
Okay. Take care, everyone. Allah Hafiz.
No.